In the previous lesson, we looked at the concept of trends in data. So we had two ways to describe a trend: positive versus negative, and then strong versus weak. Before, we were looking at this qualitatively, just based on how close the points were in the scatter plot or how far apart they were. Now we are actually going to quantify it or put a number to it, okay? And our correlation coefficient which is denoted by R, tells us how much of a trend exists between two variables. So the range for R is always between -1 and +1. I'll put that up here. A perfect negative linear correlation has an R value of -1. A perfect positive linear correlation has a R value of equal to 1. No correlation would be an R value of 0. Okay, and then we've got different quantifiers: weak, moderate, and strong, and then same in the negative sense: strong, moderate, and then weak. We have two groups of descriptors when we're discussing the correlation between two variables. One describes the direction of the correlation, and then one that is going to describe the strength of the correlation. So direction can really be negative or positive, and then strength is weak, moderate, or strong, which are denoted below. If we have a perfect positive correlation versus a perfect negative correlation, these are some examples of what they would look like on a scatter plot. Looks like, so just so you have an idea of what an R value of 1 looks like versus an R value of -1, versus a low positive or weak here, and then weak. Okay. We also have another statistic that we can use, and this is the R squared value, which is the coefficient of determination. And what this tells us is the percentage the change of one variable has on another. It has a value between 0 and 1. So for example, for a herd of giraffe, the coefficient of correlation, so this is R, between a giraffe's height and weight is R equals 0.89. Now what this R value tells us is that there's a pretty strong correlation between the height of a giraffe and its weight. An R value of 0.89 will give an R squared value of 0.64. And what this means is that as the giraffe gets taller, 64% of the change of weight is due to their change because of the height. That means that 36% here of their weight is actually determined by other factors. So the coefficient of determination tells us what percentage the change of one variable has on another. The closer you get to 1, that means that a higher percentage of the change is determined by the particular variable that you're investigating. You can actually calculate the coefficient of determination using this formula here. I don't need you to know that. We are going to focus on using technology to calculate the coefficient of determination.